Namaste, this is BSc B.Ed first semester class of Atomic Structure and Bonding. Today's our topic is bond Haber cycle. सभी खुश रहें, सभी अच्छे से पढ़ाई करें और लेट्स स्टार्ट विद आवर टॉपिक bond Haber cycle. Bond Haber process, or more commonly referred to as bond Haber cycle, is a method that allows us to observe and analyze energies in a reaction. It mainly helps in describing the formation of ionic compounds from different elements. The methodology further enables us to understand the overall reaction process through a series of steps. Bond Haber cycle was introduced in the year 1919 by German scientists named Fritz Haber and Max Born. Bond Haber cycle is mainly used to calculate the lattice energy. It also involves several steps or processes such as electron affinity, ionization energy, sublimation energy, and the heat of formation and dissociation energy. The reaction of electropositive metals with electronegative non-metals produces ionic solids. Alkali and alkaline earth metals reacts with chalcogen and halogen family elements to form compounds which are crystalline ionic solids. Ionic compounds, being stabilized by the electrostatic force of attraction between positive and negative charges, are expected to have similar physical properties. But physical properties like stability and water solubility of these ionic compounds differ much. The difference is attributed to the difference in the enthalpy called lattice energy between the ionic solids. Lattice energy is the energy that keeps together the cations and anions of the compounds in fixed positions in a crystalline solid state. Lattice energy can be defined as either energy released when different processes are held in a reaction. So bond Haber cycle is a cycle of enthalpy change of process that leads to the formation of solid crystalline ionic compounds from the elemental atoms in their standard state, and of the enthalpy of formation of solid compounds such that the net enthalpy becomes zero. So now we consider an example of bond Haber cycle of sodium chloride. The heat of formation of sodium chloride from the sodium metal and chlorine gas can be experimentally measured. Sodium solid state plus 12 Cl2 forms NaCl, and total delta HF of this reaction is minus 41,4111 kilojoule per mole. The formation of ionic solid sodium chloride from sodium metal and gaseous chlorine is not a single step process but goes through several processes. Heat changes of all the processes except the lattice energy can be experimentally measured. The process or step in the formation of sodium chloride are: first is solid sodium atom sublimes and gaseous atom by absorbing heat energy. Sublimation energy for this reaction is plus 0.107 kilojoule per mole. Gaseous sodium atom absorbs the ionization energy to release one electron and forms gaseous sodium ion. Third step is diatomic gaseous chlorine breaks into two individual atoms by absorbing bond energy. Such is each chlorine atom absorbs half of the bond energy of chlorine molecules. Next step is chlorine atom accept an electron to form chloride ion and release energy equivalent to electron affinity. And last is gaseous sodium ion and gaseous chloride ion combines to form solid sodium chloride molecules and release energy equivalent to lattice energy. So summation of enthalpy of all the processes from step 1 to step 5 give the net enthalpy of formation of solid crystalline sodium chloride from sodium and chlorine in their standard conditions of solid and gas respectively. This should be equal to the experimentally measured enthalpy of formation of solid sodium chloride. So finally we get the reaction of delta HF is equals to delta H sublimation plus delta H ionization enthalpy plus 12 fraction 21 delta H dissociation plus delta H electron affinity plus U or delta HF0 minus delta H sublimation plus delta H IE plus fraction delta dissociation energy plus delta E electron affinity plus U is equals to 0. So this is Born-Haber cycle. Thank you so much.